Well, this chapter all about, and well, they finally find out that the gravitational mass is the same as the inertial mass, and so on. But one of the points that is pinpointed here is that because of the Earth is rotating, is that the Earth is bulging out, and it says here, okay, well, they say that if you hang up a mass, I'll show you like this. I did an experiment last week, and oh, here I have it. This is just a bottle with water on a cord. Well, it's a long cord, so because I was use it as a pendulum to do some experiments, but it didn't work. It didn't work. Okay, not every experiment works. But what they did is hanging up a mass. But if you hang up a mass on the poles, the gravitational force is bigger than on the equator. And what happens, exaggerated, is that because of the Earth is rotating, the mass is also pulled up, yeah, because of fleeing away forces. Yeah, how do you say? In Dutch it's middelpuntvliedende kracht, but I don't know how it's in English. Centripetal, whatever force. But because of that, exaggerated, the bottle is not hanging straight to the center of mass of the Earth, but is a little out of line with that. And I'm exaggerating right now because it's a very small angle, but it's still valid. I mean, and that's also because of the rotation of the Earth. It swings, the Earth swings it actually out to the space. So, and that's also what is causing the Earth to bulge out. Okay. Well, what it says, I directly translate. The weaker effective gravitational force at the equator has led to the equational bulging out of by the centuries. The radius of the Earth at the equator is approximately 20 kilometers longer than at the poles. This longer radius is extra adding to the relative weakening of the gravitational force at the equator, where one is further of the Earth's center than at the poles. As mentioned in chapter 2, the gravitational pull of the Sun and Moon to have a grip on this equatorial outbulging of the Earth, and causes that the Earth will slowly change his direction in the rotation axis of the Earth. Well, that's what we're going to talk about. I've had it from this book, you know. Okay, we're going to talk about that, taking in account this whole matter, and this is the chapter 2 they mention, yeah. Because if the Earth is slowly slowing down 1/600th second per century, I have to say, well, then, like I said, billions of years ago, they had a shorter day. Well, if you calculate it about 4 billion or 4.5 billion years back, yeah, then you come out on 3 hours a day. That's very short. Well, if that happens, we calculated that in an earlier movie, you end up with an 8 times bigger rotation speed. Well, the force causing that is squared. Yeah, and because of the rotation, so it was actually the force on the equator is 64 times bigger at the equator than at the poles. Yeah, and not only that, because of that, if that happens, yeah, then the Earth will, if the forces are bigger, yes, and with higher speeds, yeah, then the gravitational pull is lower. And it will be flattened more, even more than 20 kilometers. Nowadays, it's I exaggeratedly drew it here. So this is an Earth that is elongated by the rotational forces. Yeah, and I just exaggerated the drawing. Of course, you can see that. And this is now 20 kilometers. But if the speed was 8 times bigger, then the force would be 64 times bigger, causing a bigger radius from here to there. So the Earth would be flattened even more. Yeah, reducing again gravity. Yeah, and making this force actually bigger, because you see that the force grips on the mass is influenced by the speed, rotational speed, and the distance to the center. Yeah. So if the rotation was quicker, and it had to, because there was billions of years of was there rain and waters here on Earth, according to the evolutionists. I don't agree, but according to them. Yeah, the billions of years of water, and even the crust will dissipate energy by tidal effects, so that they had to be shortened, had to be shorter billions of years ago. Yeah, we saw that fact. Yeah, and this is approved by Professor Dr. something something. Yeah. And Dr. van Bentham and Kortbeek, and Scientific American books approved this information. Yeah, so this is scientifically fact. Yeah, and I agree. I mean this is factual. Yeah. So, but then the force had to be at least 64 times bigger. So the bulge must have been bigger than 20 kilometers, as it is now. And if the bulge is bigger, then the radius becomes bigger, so the force increases again. So the minimum extra force on the equator is about 64 times, creating huge problems. The Earth would be flattened. They say that the scientists say that we as Christians we thought that the Earth was flat. Well, scientifically they are saying the same thing. Yeah, they say that we say that. The scientists say that we thought that the Earth was a flat pancake. Well, according to their science, they actually say the same thing, but they shove it in our shoes. Yeah. Okay. So you run into troubles. You really run into troubles if you consider that the Earth is a billion years old, considering that the Earth days must have been shorter, yeah, etc. But there is another thing. Now today it's the 27th of January 2010.